going to explore the idea of charges, and it's very important in the field of physics, which is called electrostatics, and it's the main idea behind the topics of electricity as well. So we'll learn about the basic ideas for charges. We'll going to call them as electric charge. It's usually a positive and a negative sign inside a circle. That's how we draw our charges. The positive sign represents positive charge and negative sign represents a negative charge. Now, there is some force involved between the charges, and we already know that the forces can be attractive and repulsive. So what it means is that if we have opposite charges, for example, if we have a positive and a negative charge, and if we bring them close together, they're going to be attracted towards each other. So it's just like, think of the idea of a magnet, how the opposite poles of a magnet attracts. So that's the attractive force between opposite charges. Similarly, repulsive forces will exist between same charges. If we have a positive charge and a positive charge, they're going to push them away from each other, and that's the repulsive force because of the same charges. Now, there's another important idea that charge is conserved. What it means is that it cannot be created or destroyed. Similar to the idea of mass and energy that we have seen before, that the conservation of energy, where the energy of the system does not change. It's the same idea that we're going to say for a closed system. The total amount of charge that is accumulated in that system is going to stay the same or remain constant. Or the charges are not going to change. They can move around, but the amount of charges will not change. The unit for charge is measured in coulombs, and capital C is the letter we use for Coulomb. It's usually represented in small units as millicoulomb or microcoulomb. The reason behind it is because that 1 coulomb is a very big unit, and it's a very big number, so that's why we try to use the small prefixes for coulombs. Now, as we have seen before, we talked about the positive and the negative charge. So let's see how many coulombs is each charge. So positive charge and negative charge, as we have seen before, are the two types of charges. Positive charge is sometimes also referred to as proton, whereas a negative charge is referred to as an electron. The amount of charge on a proton is 1.6 times 10 to the power negative 19 coulomb, and it's the same amount of charge on an electron, but with a negative sign. So let's say we have two protons brought together. They're going to have a repulsive force, but if we try to bring the two protons close to each other, the repulsive force is going to get bigger because of the small distance. Or the closer the charges are, there will be more forces. Or we'll take a look at what happens if we increase the amount of charge. Let's say we have more positive charges brought closer together at the same distance. It's going to be experiencing more force as well, more force of repulsion. So that brings into the idea of Coulomb's law, and that's also called as the electric force. So let me write down the equation, and then we'll talk about each variable, what it stands for. F is the force on the charge, on one charge. K is a Coulomb's constant. Q1 and Q2 are the amount of charge 1 and charge 2. And R is the distance between the charge 1 and charge 2. So if you remember, this equation kind of looks similar to what we have just covered about gravitational law. So let me write the gravitational law, and you will see how similar they are. The charges are replaced with the masses, and the constant is actually different. So if I write down the value for G, we already know, which is a really small number. But for electric constant or Coulomb's constant, that's a big number. It's times 10 to the power 9. And that's a huge number. That also helps us understand the strong electric force as compared to the weaker gravitational force. So let's take a look at if the force is negative. What happens if we get a negative answer for the force using Coulomb's law? What it means is that the charges have opposite signs. So if one is positive and the other one is negative, which means that the force is basically attractive. So negative force is going to tell us that there's an attractive force. So let me write down the equation again. As you can see, Q1 if it's positive. And so what happens if we get a positive force? What it means is that the charges have the same sign. And what I mean by that is that either Q1 and Q2 are both positive or Q1 and Q2 are both negative. As you can see, when the positive signs and negative signs are multiplied, we get a positive answer. So positive force means that there's a repulsive force. Now let's go back and write down the Coulomb's law again. I'll write down the Coulomb's constant as well as a reminder. Make some and help us understand how the one quantity affects the other one. So let's say we double Q1 charge. As if I put a 2 with a Q1, I get a double force. Similarly, if I double both the charges, Q1 and Q2, then the 2 times 2 will give us a 4 times the force. So the force is actually quadrupled. Another type of questions you will often see is that if we double the R, what happens to the force? So if you double the R, you actually have to square the whole part, which gives you a 1/4 of the force, or 1/4. Let's say if we halve the distance or bring them closer by a shorter distance or half of the distance than before, what happens is that your R is changing by half and you're squaring the whole part, and the half squared in the denominator goes in the numerator on the other side, which means that you have 4 times or a bigger force, or we can say the force has increased by 4 times.